going to run through some example integral problems here. And the first one, be careful because notice it appears to be in parentheses. However, this is just a regular sum of two different values. I can break this up into two separate integrals, and I can take those integrals separately. So I'm going to follow the power rule in reverse, raise this to the third power, and then divide by 3. That's x cubed over 3. Second of all, this is to the 3/4 power. 3/4 plus 1, 1 of course is 4/4, is 7/4. That's going to be my new power. So I'm going to have x to the 7/4 power, 4x to the 7/4 power. That is going to be divided by that new exponent of 7/4. Remember, when you divide by an exponent, you can multiply by the reciprocal. Or sorry, when you divide by a fraction, you can multiply by the reciprocal. So that is 4/7 times 4, which is 16/7. And so as a result, I end up with plus 16/7 x to the 7/4. And remember, if it's an indefinite integral, I do need to add c at the end. So there's my solution. Okay, moving on to problem number 2. You can see that I have the integral of 2x times e raised to the 4x squared power. I notice that the e has a 4x squared power. The derivative of that is 8x. That's my inside function. So I know I'm going to need to have an x as part of the derivative of the inside function. Notice I have an x being multiplied out here in front of parentheses. Remember, you can't break up a product into two products of integrals. So if there's a product, most likely it's going to be part of a derivative of an inside function, and that's what you see here. So I'm going to rewrite this as e to the 4x squared. Remember, I need the derivative of the inside function to be 8x. So I've got my 2x there, and of course my dx that's going to get pulled back into the equation when I take my integral. But I need a derivative of an inside function of 8x, so I'm going to need a 4 here. I'm going to need to balance that by multiplying the equation by 1/4. Okay, so what does that end up doing? That's the derivative of the inside function. That and the dx get pulled back into the function, and I actually end up with 1/4 e to the 4x squared power, once again, plus c. Okay, if I don't have that x out in front, I'm not going to be able to integrate this using the methods we've discussed at this point. So be careful when you check for that. Okay? Problem number 3. In this problem, standard 8th power function, not one I'm going to be able to expand. Of course, if I had u to the 8th power, the new function would end up being taken to the 9th power, so I'm going to keep the same inside function, raise it to the 9th, but I need to balance by dividing by 9. Meanwhile, I have this inside function. Derivative of the inside function is 5, so I'm going to need a 5 here with my dx. I'm going to need to balance that outside of my integral with a 1/5, and so I have a 1/5 out in front here as well, and the final integral here is going to be 1/45 quantity 5x plus 4. The inside function does not change. Raised to the 9th power. And once again, it's an indefinite integral, so I should have my c at the end. Final one in this column is a cosine of 5x. Notice not being multiplied by anything. There is no inside function here. It's just the cosine. Well, there's no derivative of an inside function that's being included here. We'll put it that way. So it's a cosine function. You get that inside function of 5, but I don't have a complicated inside function. Derivative of the inside function is 5, so I'll put that with my dx. I'll balance that with the 1/5 outside of parentheses. Remember, I can carry a constant outside parentheses. Integral of cosine is sine of the same thing, of that inside function of 5x. The 5 dx, that's my derivative of my inside function. That gets pulled back in. I've got my 1/5 out front, plus c. And again, keep in mind, if you want to check these, you can always take the integral, or you can always take the derivative of that function, and you can see that you should get back the original. Okay, let's move on. Now, number 5. A little bit trickier in this case, because for problem number 5, you're going to notice that I have a product. And again, I can't take this and break the product up. That is most likely going to be the derivative of an inside function, or part of the derivative of an inside function. Notice, though, that there's another inside function here, a 5x. Derivative of that is a 5, and I need to have a 5 there. I need to balance that with a 1/5 outside of my integral. Okay? Second of all, the derivative of sine of x, the derivative of cosine x is negative sine of x, or in this case, derivative of cosine of 5x is negative 5 sine of 5x. So really I need a negative 5 here, and I need to balance that with a negative 1/5. Okay? Again, because I have that sine as a derivative of an inside function, that means that cosine was an inside function, which means I'm going to have to raise the power on my cosine. That's going to be cosine squared of 5x. Okay, I'm going to have to divide by that new exponent of 2, and then I've got my negative 1/5 that I've balanced on the outside. Remember, negative 5 sine of 5x is the derivative of that inside function, and as a result, those are going to get pulled back into the function. You're not going to see that. If I want to simplify this a little bit, I can write that as negative 1/10 cosine squared of 5x plus c. Okay? Moving on to number 6. You'll notice it's a cosine function. However, the derivative of my inside function has an x squared. Okay? I need an x outside parentheses, and in this case, I don't have that. So unless I have an x, unless I have an x being multiplied by this cosine function, I don't have a way to get that derivative of that inside function. Right now, using the current processes we have, this is not going to be able to be integrated. So for right now, I'm not going to be able to do anything with number 6. Okay, moving on to 7. Same thing. Derivative of the inside function is going to be 3x squared. You'll notice I don't have a 3x squared outside of parentheses. However, unlike number 6, this is one that can be simplified relatively quickly. I can square this. And that's equal to x to the 6th plus 4x to the 3rd plus 4 dx. And now I can take the integral of that sum, taking the integral of each part separately. That's x to the 7th over 7 plus 4x to the 4th over 4. Of course, those 4's cancel. Plus 4x plus c. And I have my final integral. Moving on, problem 8. I have a square root function here. I'm going to need to rewrite that square root function as a 1/2 power. So I've got 4x squared plus 3 to the 1/2. You'll notice that I do have a derivative of an inside function. That needs to be 8x. Okay, you'll notice I have a 2x, which I'm going to position over here by my dx. I am going to need to multiply that by a 4 to get an 8x derivative of my inside function. If I multiply by 4, I have to balance by multiplying by 1/4 outside the integral. Notice with my exponent, I'm going to add 1 to my exponent. When I raise that exponent, 1/2 plus 1 is 3/2. So the whole function is going to need to be divided by 3/2 or multiplied by 2/3 if you want to think about it that way. So that's going to be 1/4 times 2/3 times 4x squared plus 3 raised to the 1/2 power. All of this is derivative of an inside function. That's going to get pulled back into the equation at the end, and so I end up with a final answer of 1/6 times the quantity 4x squared plus 3 to the 3/2 power. And remember at the end to add c. So that's what's going on there. Okay, 2 to go. Number 9, it's a secant squared. Hopefully you remember, secant squared is the derivative of tangent of x. So, as a result, I know this is going to be a tangent function, not a second power function. I only need to handle the derivative of my inside function, which is 7. So balance that with the 1/7. And I'm going to get 1/7 tangent of 7x plus c. And again, if you take the derivative, you will get the value that I started with. And the final example. This time you'll notice I have a secant 3x and a tangent 3x. Well, the derivative of secant of x is secant x tangent x. And I can use that idea here. I'm going to rewrite this just slightly. I'm going to rewrite this as secant to the 4th of 3x. I'm going to borrow a secant because the derivative of my inside function is going to have a secant 3x and a tangent 3x. Of course, the derivative of that inside function is actually 3 secant 3x, tangent 3x. So I multiply by 3. I balance that outside parentheses with a 1/3. I'm going to have secant to the 4th raised by 1 power. Of course, I'm going to need to divide by 5 there. Of course, I've got my 1/3. And notice that 3 secant 3x tangent 3x, that's all derivative of my inside function. That's going to get pulled back in when I take the integral. And so as a result, this simplifies. I get 1/15 secant to the 5th. Did make a small mistake here. That should have been secant to the 5th of 3x. And so this can be secant to the 5th 3x plus c.